Now, let's have now number 35. But take note, in your book, we have this diagram, but I think this diagram is not related to number 35. Okay, so kindly cross this out, cross this diagram out. And so we're gonna focus on this question only. Let's try here to read the problem. When two resistors, each of resistance 4 ohms, are connected in parallel with a battery, the current leaving the battery is 3 amperes. So we can simply draw this first situation, wherein if we're gonna have the battery, so we're gonna have here the parallel, which is 4 ohms, and then 4 ohms, and so the current that keeps on flowing here, the current, that would gonna be 3 amperes. Next, so when the same two resistors are connected in series with a battery, the total current in the circuit is 1.4 ampere. So if we're gonna connect them in series, and we're gonna have the same resistors, so we're gonna have here 4 ohms, and so another here we're gonna have 4 ohms, and so the total current that we're gonna flow is 1.4 amperes. Now, before we answer here, let's try to look on the general idea. Now, we all know that the total current here, so from here we're gonna have 4 ohms over 2, and so the total current for this one is 2 ohms. And so that is simply the total current, that would be 2 ohms from this part plus the resistance coming from the battery. So this one would be the resistance coming from the battery. And also we're going to have a resistance here coming from the battery. And so the total current that we're going to have here, that is simply 4 plus 4, that would be 8 ohms, plus the resistance coming from the battery. So that would be our total current. Now, looking at the theory behind, we have the voltage, the total voltage, that would be the current that keeps on flowing multiplied to the total resistance. So if we have here the circuit, if we're gonna have here a circuit, the VT, that will gonna represent the EMF of the battery, and of course we're gonna have the total current, and that is RT, and we're gonna have the total resistance. So let's do now for each case. So for this case, we're gonna have here the EMF of the battery, and the total current for this case we're gonna have 3 amperes multiplied to 2 ohms plus the unknown resistance. So here we're also gonna have the EMF of the battery, that is 1.4 amperes, and that is simply 8 ohms plus the resistance of the battery. So as you can see here, we're gonna have now a 2 working equation. Let me just simplify this one to remove all the possible units. that is 3 times 2 plus R, and then EMF, that is 1.4 times 8 plus R. So as you can see, this will gonna give us our equation 1, and this will gonna give us our equation 2. Since we have the same value for the EMF, we can now say that the EMF for equation 1, that will be equal to the EMF of the equation 2, and that would be 3 multiplied to 2 plus R is equals to 1.4 multiplied to 8 plus R. So that would be 6 plus 3R, and 1.4 multiplied to 8, that would be 11.2 plus 1.4R, and simply solving now for the value of R, that is 3R minus 1.4R, 11.2 minus 6, and then this one will gonna be 5.2, and then this one will be 1.6R. And so the value of R, that is 5.2 over 1.6, and R would be 3.25 ohms. And so here, the value for the resistance of a battery, that would be 3.25 ohms. Now, how about the internal resistance of a battery for letter B? For the internal resistance of a battery in letter B, we can simply have we can simply get any two of the formula. So EMF the battery, sorry. The internal resistance of the battery is 3.25 ohms. This one. And how about getting the EMF of the battery? We can simply choose equation 1 or equation 2. But I think it will be a lot easier if we will use the equation 1. And so the EMF now, that would be 3 times 2 plus 3.25, and that is simply 3 multiplied to 5.25, and that is equals to 15.75, or simply 16 volts. So our answer here, that would be 16 volts. Now, let me re-emphasize that the formula given in IV is V is equals to ER, that's the EMF, minus the IR. So that would be the voltage that when you look for the IB data booklet, they will gonna give you formula for 5.3. But let me just emphasize how this formula has been derived. So again, we can simply express our equation here, which is Vt equals to the total resistance times the RT. Okay, and then from here the voltage is the EMF, and then the current, of course that would be the total current, and then multiplied to the total resistance plus the R. And if we're gonna simplify this one is the EMF, and then IT times the RT plus total current multiplied to the R, And what is this? IT times RT, that would be the voltage. So plus the IR equals to EMF. And so we can simply rearrange this so that would become V is equals to EMF minus the IR. And this one is the voltage drop in the battery. This one is the battery. So EMF minus the voltage drop in the battery, then that would be the voltage that will be given across this circuit.